lab05 for predicting motion. My name is Noah Charles, and this is for the class Physics 2211. For my lab, I decided to go with one of the prompts that we were recommended to do, which was to predict the motion of the world's largest rope swing. My calculations were based heavily in Newton's second law, where we found that the prediction motion through the derived velocity update formula. Our overall conclusion was yes, that you can use the velocity update and the position update formula to predict the motion of someone jumping off of the world's largest rope swing. We'll play this video a couple times throughout, so we'll go ahead and save it for later, but this is just an overview. The fundamental physics principles that were used were again rooted in Newton's second law, which states and relates that the net interaction between the system and the surroundings to the observed motion of the system. The system in this case was the person itself swinging, and then the surroundings were the arc, the air, the gravity, the rope, and any other external forces. What if? This was for the what if section, where we also decided to calculate the drag. So this is the formula that I used for that. And at the bottom is the velocity update formula that we were able to derive from Newton's second law. These were the steps that we decided to use to carry out our lab. For step 1 or step 2, we decided to analyze the video. So I'll go ahead and play it. This shows them running off the cliff and then swinging and then swinging back, and now it's a different person. So in this section, we listened a lot to the audio and like the behind the scenes stuff. We were able to find out that the extended length of the rope was 130 feet, which is approximately 39 meters. And then because this happened with so many different people, we went ahead and assumed the average mass to be around 62 kilograms, or about 130 pounds. And then we also assumed that the final position was about 100 feet from the ground, because they said that they reached a peak of 100 feet when they were in the air. Some of the assumptions that we made to simplify this equation was that they jumped from the rope being fully extended, since they kind of jumped from the cliff and not directly from the top to the bottom. And then we also assumed that they jumped from rest for simplicity's sake. To create the computational model, first we set up what would actually be drawn on the graph, so that's what's seen here. Next, we went ahead and established our initial conditions. So we plugged in the mass, we plugged in the position vector, the initial position, as starting with the rope fully extended to the left, so negative 39-ish meters. We plugged in the spring constant, which is 10,000 newtons per meters, and this is just the general stiffness for any climbing rope. And then for B, for the drag constant, when we did decide to plug it in, we went ahead and just guesstimated based off of lab02 and the processes we used there. Next, we went ahead and plugged everything into the calculation loop. We went ahead and we calculated the spring forces that would be present, and then we calculated the gravity force for near Earth gravity. And then depending on whether we were testing for a drag or not, we would plug it into the drag formula, which is shown right here and was shown in an earlier slide. Then we use the velocity and the position update formula to actually plot this motion. So I'll go ahead and play the videos that we got. So this is our predicted motion, just your general swing. It would go all the way to the end, and then once it hits the top, fall back down. And then I'll play this one again so you can see that it's the same general shape. Swing all the way, hit the top, and then go back down. So what does this mean? Does Newton's second law allow for us to accurately predict and analyze the velocity and position of the object? Yes, it does. We were able to see a plethora of different options for depending on the different things that were involved, and the velocities and like the shape, the general shape that the swing made was very, very similar. And then throughout the different labs that we've done through the semester, you can also see the pattern of how much Newton's second law has allowed us to predict motion. Lastly, what if drag was involved? You can see that it's a very minuscule difference because we use the similar drag constant from our previous labs. This just shows that if you look in the very, very right hand corner, it does make a difference. It's just not as significant as some of the other forces like gravity. So sources for human error, again, we estimated our drag constant, so this could be larger depending on the actual person and their mass and velocity and surface area. And then we also assumed that they jumped from rest for simplicity's sake, which would have a minuscule impact on our overall velocity. And then lastly, we assumed that the peak height was 100 feet because they said that the peak height was 100 feet, but they could have been just throwing out a rounded number. So I hope you enjoyed this lab and learned a little bit something about projected motion and predicted motion, and that how simple it can be to use the velocity formula and the position update formula to find it.